Welcome back. Let's continue with this lesson. We have seen that we can describe a projectile motion through words, explaining what we see happening. We can also describe it making use of equations, and we can solve problems in terms of finding where that object is and perhaps how fast it's moving as well. And also we can use these equations to even calculate the time it takes to move from one point to the other. Okay, now a whole lot of other things that we can do with these equations. But let's move on now and see if we can represent what we have been describing using words by making use of graphs. Okay, something very important for you to know and understand, because you can't deal with motion without talking about graphs of motion. And it is very likely that even in the exam you will have to work on problems based on graphs of motion. Now let's have a look now. Remember that with the projectile that we had, it moved upwards. It is actually thrown upwards with some initial velocity. And as it goes up, it reaches a point, okay, where it stopped. So we know that the final velocity there is 0. Okay, let's just look at that first instance there, the first journey of the ball from where it has been thrown upwards to where it stopped, the maximum height it reached. Now, we say that it was thrown upwards with some initial velocity. So if I were to draw a velocity time graph for it, I may have something like this and say it was thrown up with some velocity. But as it moved upwards, its velocity decreased steadily until it became 0 at the maximum height reached. It became 0 at the maximum height reached. Now, this first part of the graph here, as I've indicated here, this is a velocity time graph. It shows the upward motion of the ball. Now, upward motion of the ball also taking into consideration that, remember that we took our upward direction to be positive. Okay, now if the upward direction is positive, our velocity upwards is positive, so hence that value there, positive. But this positive value, we see it decreasing until it became 0, okay, at the highest or maximum height reached by the projectile. At that point, we also realize that it took half the time to reach the maximum height. Hence, in my graph here, I've actually noted the time, this point here, as t half. That tells you it's half the time of the whole journey. Okay, now let's now look at what happens in the next part or next half of the journey of the ball. The next half of the journey of the ball starts from the maximum height reached. The ball comes down, it increases its velocity as it comes down. But coming down, by implication, would mean that if the direction upwards is positive, the direction downwards is therefore negative. And therefore the velocity of the ball as it comes downwards is actually negative, because it's in the negative direction. And hence, in our graph here, you would see that the last half of the journey shows a negative velocity. The velocity is increasing in the negative. Remember that this negative doesn't have a mathematical meaning, that negative. So that negative just tells us that the velocity is in the negative direction. So here it's negative. Now, it means that the velocity is in the opposite direction. And in that opposite direction, the last half, it's actually half again the total time. So from there to there, half, from there to there, half. So together they give you the whole time. Okay, so that will be timeful. By timeful, the full time, the object is now back to where it was thrown upwards. And that is the graph there. So that is negative. Okay, I hope you've understood what is happening here in terms of the graph representation. See you in the next section and enjoy your questions.